The USACO open exam is coming up this weekend. You gotta know the drill, but it's gonna be epic because we got one more video before then. Okay, one more. Actually, I don't know what it's actually gonna be before because it's gonna be Friday at 1 p.m. But we'll see if you get to catch it. Hello everybody, I'm Kara, and today we're gonna be live solving the USACO 2019 US Open Silver. Did I say silver already? Problem 1 left out. Very cool. And the reason we're doing USACO open exam contest problem is because those are usually generally a bit harder. So let's see if we can do this one live. Alright, so Farmer John is attempting to take a photograph of his herd of cows from past experiences. He knows that this particular endeavor has never ended well. This time he has purchased an expensive drone. Impressive. So to make them look as good as possible, he wants all of them to be facing the same direction when the photo is taken. So right now they're in an N by N grid in a fenced-in square pasture, so like that. Okay. And basically what he could do is he could shout at any row or column and cause the whole row or column to turn around, okay? However, he is unable to make all his cows face in one common direction, but the best he could do is get all but one. So now we just gotta find that one cow that can't be facing the same direction. And then it basically just gives you a grid and you have to figure it out. So how do we do this? This seems a bit hard. So in this case it's RLR, RRL, and then LLR. So basically if you flip this one, then it's, okay, so what's the best way to do it? So if we flip this guy over here, then it becomes, oops, that's not what I wanted to do. How did I do that? Whoops, I accidentally rotated my view, god dang it. Okay, now we fixed it, we're good. And then we switch this guy and it becomes LLR, and then we flip these guys and then boom, we got a bunch of L's over here. And that one pesky boyo over here, the stupid cow, god dang it, what do you gotta do this to us, is gonna stay R. So how do we figure that out? So let's think about it this way, right? Like, if each row has like 1 R, 2 L's, 3 L's. Oh wait, let's go back to the original. Okay, so the first row got 2 R, 1 L. The next one got 2 R, 1 L. The next one got 2 L, 1 R. And then over here we got 2 R, 1 L, 2 L, 1 R, and then 2 R, 1 L. Okay. So basically, once you flip a row, it basically swaps these two, and then it changes stuff here in a way that I have no idea how to figure that out. Huh. This is weird. I have not seen a problem like this before, so how can we do it? So why don't we flip this guy? Well, we have to see how it affects it. So basically, two things switch. Wait, let's go back to what we had before. So if we switch this, then this moves here, and this moves here. So nothing changes, and then this doesn't change, so none of these guys change. Okay. However, if they're non-symmetric, then it does change. So if we swap this row, then this thing switches. Oh wait, no, I'm trolling. Oh, so when you switch this, so this becomes LRL. So these two things swap, and then over here, for each one of these, you subtract one from the, for in this case, you subtract 1 R and add 1 L. In this case, you subtract 1 L and add 1 R. In this case, you subtract 1 R and add 1 L to these counts over here. But does that help at all? Does it? So let's see. Well, why don't we fix which cow is going to be the end? Is there a way to check quickly whether a cow is going to work? Well, the idea to solve these problems is usually to find something that doesn't change. Well, so obviously, like the total number of R's doesn't change. Also, doesn't matter R or L. Like if you could get R, wait, let's see. So if you get R, L, 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 is there a way to change this to L, R, R everywhere else? So we flip this. Oh yeah, that you just flip the 3 rows. So it doesn't really matter whether you get all L's in 1 R or all R's in 1 L. It doesn't really matter. Well, okay, let's just try fixing a cow, right? Let's see. So we have R, L, R, 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 L, LLR, and we fix this cow, right? Then the only time that this guy changes over here is if we change this one or we change this one. Well, this doesn't really work because how do you know whether it's never possible? Well, why don't we try it on a 2x2? Let's see, R, L, L, R. Oh, but there could be multiple such cows, or there could be no such cow. So it's not necessarily there exists one. So I'm assuming then we just have to go through it and see whether each one works. So how can we tell quickly if something works? So let's say we have R, L, R. How do we make this all? Oh, we just flip this and then flip that. But how can we just look at this and know that it works? Well, let's see. So basically every single cow is affected only by 2 columns, right? It's like the one that it's in, basically. It's only affected by chaining these columns. So basically the number of times, so basically the direction of this is basically whether or not the sum of this plus this. Okay, let's say that R1 is the number of times that the first row is flipped, R2 is the number of times the second row is flipped, R3 is the number of times the third row is flipped, and then C1, C2, C3. Okay, so basically the color, or let's just call it color because direction is too long. So let's say this is color. So the color changes if R1 plus C1 is odd, right? But the color stays the same if R1 plus C1 is even. So we want all of them, okay, let's just say we want all of them to be R, right? Then we know then that R1 plus C1 is even. Then we know that R1 plus C2 is odd, and then so on and so forth. We get a bunch of things. And you get R1 plus C3 is even. And then we could just fix that R1 is even, right? Because if we want to make everything, like, could we fix that R1 is even? Could we just say arbitrarily that R1 is even? Yeah, because if we want to change R1 from odd to even, we just flip all the rows and then flip all the columns, and then it's the exact same thing, except R1 is now even if it was odd before. So we'll just say that R1 is even, right? That means that C1 has to be even as well. C1 is even. C2 is what? C2 is odd. C3 is, and then if we do the same thing, we could find that what R2 is, and then we know that R2 plus C1 is even, which means that R2 got to be even, and then but then this is a contradiction here, because then this has to also be even, and then this is another contradiction. And hooray, we found two contradictions, so clearly if we take out this guy, it's not going to work, right? Well, yeah, so basically we want to find something that has like a bunch of contradictions if we take it out. So like the only condition we take out is this, and we fix that R1 is even, so yeah, this is the two things. And then this is actually valid, because then we can make R2 odd, and then this works. Okay, so that makes sense. Wait, this actually makes sense. So basically what this is saying, right, is that like, if we fix that R1's even, right, then we could automatically find the parity of all C2, C1, C2, C3. And then we had to make sure that all the other columns are valid. I mean, all the other rows are valid. And if we know what the like parities of C1, C2, C3, C4 is, then we basically immediately know whether the rows are valid. Okay, that makes so much more sense. Okay, so let's try to figure out the actual algorithm for this. So basically, if you take out one cow, all of the rows have to be multiples of each other, basically, once you take it out. Okay, so basically we go through all the rows, right? And we check, like, we had to make sure that there are, like, all multiples of each other. Because, like, right now these two are, like, multiples of each other, right? They're either flipped the same way or they're flipped from each other. But how do we figure out which ones are valid, though? Okay, so basically we'll keep track of two arrays, right? We'll keep track of row 1 and row 2, right? Let's make it a little bit more complicated. So basically we look at the first one, right? And we're like, okay, so we have, this is our, this is one variable. RLR is stored in one variable. And then we're like, RLRR. Okay, so far we haven't decided on what our things gotta be equal to. And then we go to the next one and we look, oh wow, it's actually basically the same as this except flipped. And as long as it's flipped, it's okay. So now this one becomes the odd one out because now, like, it doesn't match up with the other one. So the only way to make this work is to make it equal to one of the other ones. And we see that the way we do that is we have to take out this one. Yeah, we have to take out that one. And we see that this is the odd one out. Okay. So how do we do this? Is this good enough? And how could there be multiple? In what case is there multiple cows that do that? Okay, yeah, so basically what we figured out is that the rows have to be multiples of each other once you delete that one cow. And like either they're the right way or they're flipped from each other, but as long as they're follow the same pattern, then it works. However, if there's 3 different row types, then it doesn't work at all, because if there are 3 different row types, you could change one to match another one, but then the third one is not going to equal either of the other 2, and it's just not going to work. So you got to make sure that there's only one odd row out, and then we could get rid of one of the things in that odd row. Because remember, we only get to change one row. Okay. And also we can't have like 3 of one row and 3 of another row, because then you can't change all of the rows to be the same. Or could you? Is there a way to do that? No, you can't. There's no way to do that, because you can only change one row. Okay. So we just have to make sure that there's 2 rows, and one of them only has one of its type, and then the other has the rest of the rows. Okay. Let's do it. Noisu. Okay. F-stream time. And then let's add our thingamajig. So we got an int n, and then we got a we'll just have a char array. Nice. And then we'll read everything in. So we're gonna do I other rows, and then j goes from left to right. So we'll do f in dir I j. Okay. Okay, and then we'll also have a char r1 and char r2. And for a 2x2, basically anything works, right? Wait. So if you have a 2x2 and you remove the top left corner, like everything else works, right? Like R, L, L, easy. R, L, R, that works. R, yeah, everything works on a 2x2. So basically you just remove the top left one. Okay, so we'll make our array R1, 1000, and then our other one will be R2, and then we'll have a count of how many of each one. Okay, so basically, if n equals 2, then we're just gonna immediately see out 1, 1, 1. And then otherwise we will, actually this should still work with our logic, so we don't need to do that. So then we'll set R1 to our first row, and then R2 will also set to the second row. Okay, so now we have our 2 reference rows. Actually, we had to first check that R2 is not the same as R1. So, okay, so let's first check equivalence. Okay, so let's make an equivalent thing. Bool equivalent char A, char B. And then basically what we'll do is we will, and then what we'll do is we will, and then basically we'll look at the first 2, right? If they're opposite, then we know that B has to be the flip side of A or they're not equivalent. So we will first check bool flipped equals false if B0 is not equal to A0, then flipped is equal to true. And then basically for int I equals 1, I less than n, I plus plus, if ai is equal to bi, or not equal to bi, then we return false. However, we want to make sure that if it's flipped, then we do the opposite. So how do we flip something? I think XOR works for this. Yeah, XOR works for this. So basically what will happen is this goes here, and then we XOR it with flip. And basically what that does is, if flipped is true, then it's like, it just takes whatever's here. But if flipped is false, it flips this statement over here, so now it's negated. If this doesn't work, okay, you know what, why don't we just do it simpler? I don't need to complicate things unnecessarily. So, if flipped, if not flipped, and, else, if flipped, and then, oh wait, yeah, we can just do if flipped and ai is equal to bi, then we return false as well. And then if it gets through the whole thing happily, we return true. Okay, so basically we'll just do while r2, or while equivalent r1 comma r equivalent r1 comma r2, and well, we had to keep track of, let's say int j equals 2 now, and j is less than n, then we'll set r2 for int I equals 0, I is less than n, I plus plus, r2 I is equal to dir j I. Okay. So basically what this does is it keeps changing R2 until they're equivalent, or until they're not equivalent, sorry. And basically j is going to tell you where the next one that we haven't looked at yet is. So while j is, and basically j will be past n if r1 and r2 are equivalent. So while j is less than n, we're basically gonna do, what are we gonna do? We'll basically do if equivalent r1 comma dir j. So if r1 is equivalent to the current row, we'll add it to r1's count. And then otherwise, if equivalent r2 comma dir j, then we add to count 2. And wait, we have to make count 1 equals 1. We should set count 1 equal to 1 at the beginning. However, if it's not equivalent to either of them, then we're automatically done. So then we just see out -1, f out -1, and we're done. And then at the very end, if both the counts are greater than 1, then we also have to return 1. If count 1 is greater than 1 and count 2 is greater than 1, then we gotta count -1 and return 0. Okay. However, if it's valid, like our counts are not too big, then we have to look in row 1 and see if there's, and then, well, we have to look at the one with the count is equal to 1. So we ideally want to do row 1, right? Because we want to have the lowest row index. So if row 1 or r1, wait, what? Oh, if count 1 is equal 1, then we'll look through row 1 and see if we can make it equal to row 2. So we'll just go through it. So for int I equals 0, I is less than n, I plus plus, we'll try flipping it. r1 I is equal to, oh, but it's chars, I hate chars. How do you flip it? Okay, fine, let's see. If ri equals r, or r1I is equal to l, and then vice versa. And we should have a temp, chars temp equals original r1I. Okay, so we flip it, and then we check if it's equivalent to r2 now. We'll see how 1 comma, plus I, yeah, I plus 1. And then we return because we're done. And then we gotta set r1 back to its original state. And then at the very end, we got to go through here, and we gotta go do it for r2 and make sure that r2 can be changed to r1. Wait, if r2 could be changed to r1, then r1 could be changed to r2, right? Oh, okay, so I guess we could just figure out the row where they differ, and then we could figure out which thing to change. Okay, so we'll just have int j, or int k, let's say, equals 0, and then, or let's say -1 for now. And basically what k is going to be is like the index that is different between the two that we need to change or take out in order for them to be the same. Wait, how could there be multiple indexes that if you take it out it'll be the same? No, whatever, yeah, so it should be fine. And then if we find the one that works, then we just break. But we should also check if r1 and r2 is equivalent, right? So if r1 and r2 are equivalent, then anything works. So we'll just take 1, 1, right? If equivalent r1, r2, then we just see it, we'll take it from the top. Or yeah, see out r1, see out 1. Alrighty, and then basically, if we have this I over here, so if k is equal to -1, then we have to see out -1, right? Because that means none of them could be switched in order to make them equal. However, and then after that, if r1 is equal to, wait, oh, maybe I should not use j again. So maybe we'll do int c is equal to j, and then we'll do c here, and then j plus plus. So if count is 1 is equal to 1, then we could change it in r1, so we'll just return 0, or 1. F out 1. F out 1, and then ri, or k. However, if our count 2, yeah, okay, else, that means our count 2 gotta be equal to 1, in which case we gotta print out the row number of our r2, which is gonna be j, f out j, and then I, or k plus 1, and then return 0. Okay, there, this should work. Very cool. and then the left I dropped in. No segmentation fault. Whoops, C. Yikes. It's gotta be C over. Oh, bro, wait, why? I didn't even J++ here. But anyways, I guess it didn't matter. Yeah, so it basically just found that. And then why don't we flip these two guys to the top? So it's trolling basically. So where does it F at 1, 1? Okay, let's see what it gets for J. So it gets 3 for J. No, what? Why is it getting 3? Why is R1 equivalent to R2? So it sets R2 to that. Okay. So it thinks that our first row is equal to our third row, which is not true. Wait, well, where did it get the 3? See how J. Oh, so the first time it's comparing. Oh, so then we gotta do J minus 1 over here. Okay, so basically we got J is equal to 2, which is the right thing. Wait, we should probably just go through the whole thing. So let's call it 0. This is 0. Get rid of C. And then let's make a for loop. For int C is equal to 0. C is less than N. C++. Not C++. Okay. And then this should work. So it's going through this for sure. So let's see what are cout count 1 and then count 2. 1 and 1, how do you get 1 and 1, bro? So these things are from the beginning. So this is 1 and then oh, we don't need this. Whoops. Okay. Okay, good. 2 1 is what we want, and then we get left out is 2 1. 3 1, right? So 3 1. Yeah, so 3 1 works. Okay. So we had to do J plus 1 here. Okay. And then if we flip it back, it'll still work. Alright, nice. So we'll basically get rid of all our C outs and we should be Gucci. Alrighty, let's test it out. This is gonna be so cool. Watch this. It's gonna be first try, I bet. No, actually, we're not gonna say that because it never happens. Except that one time, berries. Come on, that was too good. Oh, no, what? Wait. God dang it, what's wrong with 12? Bro, let's go. Well, I mean, it's technically not done yet. Let's try to figure it out. Did not expect that. Okay, did not expect that. Why don't we just do J equal N here? Yeah, that should not be the problem. Yeah, okay, I'm just gonna change this to J is greater than or equal to N because I think that is the problem, and then we should be Gucci. I don't know why exactly that would make sense. Because is it possible that this got trolled? So let's say J is equal to N minus 1, then it would put the last thing into J. Wait, so it might get that they're equivalent, and then go into here. So it was J minus 1. Well, okay, I'm just gonna test it. That should also work. Let's work, come on. Don't troll me like that. Did I submit the wrong one? Oh, I think I submitted the wrong one. Yikes. Please, I beg. Come on. Let's go! We did it! We are cool, I think. No, probably not, but like, hope this was helpful. Actually, that was pretty good. Nice. Let us go, but I still don't completely understand why we changed that to J. I don't know, I just tried it and it worked. Oh, it's so big brain. Oh, that's oh. Okay, so basically the reason why this worked and not the reason I thought I wanted it to work, because like this never gets satisfied, so it never goes into this. So we can literally just delete it and it'll still work. The reason why that is because let's say all of them are equivalent, right? Then if you flip stuff, you're gonna make everything the same. There's no way to have one single cow like not flipped. I forgot that case. But yeah, basically, they didn't check for that, but like, or no, I just like put a thing that didn't do anything in there for the wrong reason, and it still worked. But now this should work. This is like the actual proper code. Let's prove it to you that this is beautiful. Okay, so you go down here, you go here, you go there, you go there. Alrighty, let's see this. Epic. Okay. Now we have officially finished it, we understood the whole thing, very cool. I tried to do a little bit of a harder one because the US Open is coming up. Hope this was helpful. If you guys want more of these videos, just let me know down in the comments. Thank you guys for watching so much. As always, if you enjoyed the video, leave a like and subscribe for more. Thank you guys for watching again, and see you guys next time.